Hello everybody, this lesson is from Unit 4, Lesson 1, and it's from the Factoring Polynomials unit, and it's just an introductory lesson getting you ready for the other concepts in this unit. So in this lesson, we're thinking about common factors, and a factor is a number that is multiplied to get to another number. So to determine if a number is a factor of any given number, it should divide out evenly into that number. So in this example, that first one, is 6 a common factor of 24 and 56? If you were to take 24 and divide by 6, you would end up with a whole number. 24 divided by 6, it goes into 24 4 times. So since this one comes out to be a whole number, it's a factor of 24. But then when you were to check for 56, if 6 goes into 56, well, the closest number that goes in for 6 is actually 54. And then if you were to subtract, notice we are not getting a whole number. We end up with a decimal. And with this one, since it's 9.3 continuing on, we end up with 9.33 repeating. Since you end up with a decimal, it is not a factor of 56. So it's a common factor of 24, but not of 56. With the second example, is 12 a common factor of 60? If we were to do 60 divided by 12, 12 goes into 60 and even 5 times. And if we were to check 168 divided by 12, 12 goes into 168. Long division here, and then 12 goes into 48 4 times to come out evenly. So it goes in there 14 total times for 168 and 5 total times for 60. Since both of them are integers, then this 12 is a common factor of both. Perfect squares is another topic in this lesson. If you think of what a perfect square means, you're multiplying a number by itself to equal this perfect square. And so when they want you to write a perfect square as a power of 2, they want you to think about what number am I squaring to get to this number, or what number times itself equals the number given. So for this one, 64, I need to think what number am I multiplying by itself that equals 64. And many of you may already know this one, but 8 times 8 is what you multiply by itself to get to 64. So as a power of 2, you would write this as 8 squared, because 8 squared, or 8 times 8, equals 64. Another example, 121. Think of that as being 11 times 11. So as a power of 2, I would write that as 11 squared. 36 is 6 times 6, so I would write that then as 6 squared if I wanted to write it as a power of 2. It's a little bit different when you introduce variables. You're still thinking, what am I multiplying times itself to get to that number? And if you remember the rule for exponents, if the base is the same, you're adding the exponents. So you're kind of thinking, what number am I adding with itself to equal 10? So, for example, x to the 5th times x to the 5th. Since the base is the same, you add those exponents, 5 plus 5, that's how you get 10. So as for how you would write it as a power of 2, you would have x to the 5th and that entire value squared, because you're multiplying x to the 5th times x to the 5th. And in this last example here, I have a number and I have a variable. So the number, what times itself, equals 169. If you know the reverse of this, you could take the square root of it to figure out that integer value. The square root of 169 is 13. So this is actually 13 times 13, or 13 squared. And then t to the 12th. Remember with exponents, you add them when you multiply with the base being the same. So what number adds with itself to get to 12? Well, you'd have t to the 6th times t to the 6th, because t to the 6th equals 12. So then you'd write it as t to the 6th squared. So all together, You could have it as 13 squared times t to the 6th squared, or you could write it, this would be the same if you had 13t to the 6th and that entire value squared. So you could have it separated out, or you could write it together as 13t to the 6th, all raised to the 2nd power. And then just some, for listing out factor pairs, the last topic in this lesson, just pay attention if they want the positive factor pairs or negative factor pairs. For the positive factor pairs, you're listing the factors that you would multiply, so the 2 pairs that you multiply to get to 15. So don't forget about 1 and the number itself. So just get in the habit of writing, well, I could do 1 and 15. Both of those are positive, so they're positive factor pairs. And the other one, I could do 3 times 5, or 5 times 3 would be the same thing. So these are the positive factor pairs of 15. This next one is negative factor pairs of 38. So you'd be multiplying 2 negative numbers to get to 38. So we could have a negative 1 times a negative 38. You could also have a negative 2 times a negative 19. So they're negative factor pairs because both of the numbers are negative. And this last one, factor pairs of a negative 24. So since this is a negative, I know that the 2 factors that I'm multiplying, one needs to be positive and one needs to be negative. So if I just list them out, negative 1 times a positive 24, that would equal negative 24. I could have negative 2 times a positive 12, that would equal negative 24. Negative 3 times a positive 8, I could have negative 4 times a positive 6 as another example. But that's not the only list. Like these would all multiply to negative 24, but you could have the opposites. You could have a positive 1 times a negative 24, and a positive 2 times a negative 12, and a positive 3 times a negative 8, and a positive 4 times a negative 6. So it helps to just list them out where the first term is all negative, and then list them out again with the opposite terms being negative when you have to list out the factor pairs for a negative number. Just remember there's 2 possible combinations because both of these groupings would multiply to equal a negative 24, but they're actually different factors.